Students, we completed our 11th chapter, trigonometry. Very interesting and important chapter. So there are various applications of trigonometry. Where do we use trigonometry? What is the use of the trigonometry? Where we use? So there are so many applications of trigonometry which you are going to study in intermediate first year. Intermediate first year, there is a big chapter, very big chapter, total trigonometry only. Total first year intermediate syllabus, there will be around 30% of the syllabus is trigonometry. So you will study in detail in about the trigonometry and all the applications. But in our 10th class, we are given one important application of trigonometry where we use the trigonometry. So by using the trigonometry, we can find heights of various objects. We can find the height of the object. Suppose there is a big tree. We can't measure, we can't take the tape and we can't measure because it is a big tree, it is difficult to climb and it is difficult to measure. But without going to that tree, standing at a far distance, we can find the height of the tree. We can find the height of the tree. Similarly, we can find the height of the mountain. We can find the height of the pole. We can find the height of the building without actual measuring. Just by standing at some distance, known distance, we can, by seeing, we can tell the height. So that is one of the application of trigonometry. That means we can find the heights of various objects, a height of a mountain, even height of the Everest. Everest, you know, around 8,848 meters. So very big mountain, tallest mountain in the world. So nobody measured it. Nobody took the tape and nobody measured. But by using the applications of trigonometry, so they measured the height of the Everest. Like that, any height of any tower, any mountain, any tree, any object, any building, any height we can find. Not only that height, we can find the distance between two objects. Suppose there is one tree, there is a tree there somewhere there and we are standing at a distance. So we want to know, without measuring, we want to know how many kilometers or how many meters we are from the tree. What is the distance between the tree and the object, or distance between the two trees, distance between the two objects. So therefore, one of the application of trigonometry is find heights and distances. Heights and distances. We can find the heights, we can find the distances. So that is our 12th chapter, students. 12th chapter, go to the textbook, 12th chapter, applications of trigonometry. Application means where do we use the trigonometry? Where? Why we have to study trigonometry? What is its purpose? So applications of trigonometry. This is the 12th chapter. Applications of trigonometry. See, suppose there is a tree. So whatever object is standing on the ground, whether it is a tree, or a pole, or a mountain, or a building, we draw a vertical line. Building means we don't draw building figure. If it is a tree, we don't draw tree figure. So whatever vertical object is there, we draw a line, that's all. Suppose if it is a tree, this is a tree. Suppose the question consists a building, this is a building. Suppose question consists a tower, this is a tower. Any object, we draw a vertical line. This is the ground. This is the ground. We have to find the height of this tree. We have to find the height of the tree. So to find the height of the tree, we don't measure actually by taking the tape. We use the trigonometric formulas to find the height of the tree. So this distance we should know. Because it is on the ground only, no? Ground easily we can measure. Climbing the tree and measuring will be difficult, but ground means we can measure. So suppose we are standing at a point P, this distance distance is known. From here, there is an instrument. There is a mathematical instrument. It will have two lines like this. One we keep parallel to this, and another we adjust such that this angle we can measure on the protractor. We keep a mathematical instrument here on which it is like a protractor. Angles will be there. So angle will be recorded. So there will be two sticks. One we keep like this, another we keep like this, and we measure the angle. So if you know this angle and if you know this distance, using these two we can find the height of the tree. So this is the concept we are going to apply in this chapter. So this distance will be given, this angle will be given. Question is, find the height of the tree, height of the mountain, height of the pole, height of the building. Very simple. But drawing the diagram is very, very important. In every question we have to draw the diagram. Maximum 100% cases, in all the cases it will be right angle triangle only. Because this is the ground. This is the ground. We are standing here. Where we are standing? P. So this is the tree. Tree will be drawn vertically, making 90 degrees with the ground. Whether it is a tree or a tower or an object, any object when it is standing on the ground, we have to feel that it is 90 degrees, making 90 degrees with the ground. So it is a right angle triangle. So if this is given and this theta is given, we can find the height by using any ratio. So accordingly, suppose if this problem deals with these two sides, we have to take tan. Tan is opposite by adjacent. We can take cot also, adjacent by opposite. Suppose this is known, this we have to find. Accordingly, we can choose the ratio. So that is the concept. And see, there are two types of measuring the angle. See here, suppose the object is here, object is on the ground, and we are standing on the building. From here we are observing the object. We are on the top of the tower, we are observing the object. From the top of the tower we are observing the object. So here this angle will be given. That means if we are looking down, if we are on the top, object is here, we are looking down, this type of angle is called angle of elevation, depression. Angle of depression means we are on the top of the tower, object is below us, we are looking downwards. If you look downwards, the angle formed is called angle of depression. Next, the object is here, we are standing here, we are looking top. We are looking top of the tree. So this angle formed is called angle of elevation. Angle of elevation. So these 2 points you should know. Of course, it is very easy to remember. If you see upward, the angle formed is called angle of elevation. If you are on the top and looking down, the angle formed is called angle of depression. So write small definition for angle of elevation, angle of depression. First write down the chapter name. All of you write the 12th chapter name, applications of trigonometry. Applications of trigonometry, that is the chapter name. Of course, continuation of trigonometry only. Write down. By using, write down, by using the concept of trigonometry, by using the concept of trigonometry, we can find heights of various objects. We can find the heights of various objects. Heights of various objects. heights of various objects. We can find the heights of various objects and also distance between two objects. Distance between two objects. Heights of various objects and distance between two objects. Heights and distances. The chapter name is heights and distances actually. By using concept of trigonometry, we can find the heights of various objects and also distance between two objects. Over. Now, second point. Second point. Write down the side heading angle of elevation. Second point, side heading angle of elevation. Angle of elevation. Second point. Now see, this is called observing point. What is this point? Observing point. That means we are here. We are observing from here. That is called observing point. Which point we are observing? Where we are seeing? We are seeing the top of the tree. We are looking at this. So from this is the observing point. This is the object. Which is above? Object is above. Observing point is below. So this, that means we are looking top like this. So that angle formed is called angle of elevation. That definition only I am giving. Write down. Write down angle of elevation. Second point. If the object is above the observing point, object is above the observing point. If the object is above the observing point, the angle formed is called angle of elevation. If the object is above the observing point, the angle formed is called angle of elevation. You can write this. You can draw this figure. This is the observer. This is the object. So object is above, observer is below. So this is angle of elevation. Draw this figure. Angle of elevation means looking top. After that, write down the third point. Third point, angle of depression. Angle of depression. If the object is, write down, object is below the observing point. Below, this is below, this is above. Object is, if the object is below the observing point, object is below the observing point, object is below the observing point, the angle formed is called, angle of depression. Angle formed is called angle of depression. You can draw this figure. So this angle is called angle of depression. Angle of elevation, angle of depression. These 2 points continuously there we will get in the exercise problems. We have 2 exercises, and in every problem we will get angle of elevation, angle of depression, these 2 words. So you should know, if you are looking top, the angle formed is called angle of elevation. If you are already on the top, looking down, the angle is called angle of depression. Draw this diagram for the angle of depression, draw this diagram for angle of elevation, and after completing this, so nothing, no new formulas, no concept, already we studied in the trigonometry, everything we studied, all the 6 trigonometric ratios we studied, and angle table also we studied, 0, sin 30, sin 45, sin 60, sin 90. Similarly for all the 6 trigonometric ratios for different, for some specific angles we studied, same concepts we are going to use, no formulas. But first thing is, very important thing is drawing the diagram. Read the question, draw the diagram, then solve the problem. 3 steps. First reading the question, then drawing the diagram. After getting the diagram, then we can easily solve. Students, all of you open your textbooks. All of you open your textbooks. Compulsory get the textbooks. 302 page number. 302 page number. All of you open 302 Excel 302 page number, exercise 12.1. Exercise. See the first question. A tower stands vertically on the ground. See here. I said drawing the diagram is very important. This is the ground. This is the tower. Tower stands vertically on the ground. This is the tower. From a point which is 50 meters away from the foot of the tower. If PQ is the tower, what is the top of the tower? P. Foot of the tower? Q. Foot of the tower, top of the tower. Foot of the tower, top of the tower. From the foot of the tower, we are standing, this is the observer. Observer is standing at a distance of 15 meters. See, there is a tower PQ. This is the foot of the tower, this is the top of the tower. Top of the tower, foot of the tower. From the foot of the tower, we are standing at a distance of 15 meters. From here, 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is 45 degrees. So we observe the top of the tower. We observe this top of the tower. The angle of elevation is 45 degrees. Elevation means looking top. What is PQ? Tower. P is the top of the tower. Q is the foot of the tower. From the foot of the tower at a distance of 15 meters we are standing here. So we are observing the tower, top of the tower, the angle of elevation is 45 degrees. Question is, what is the height of the tower? What is that H? Write down. Write that description here. Write down. Let height of the tower PQ is equal to H. Let the height of the tower PQ is equal to H. Let O be the observer or observing point. I am introducing that figure. PQ is the tower. Let its height is equal to H. O be the observing point. Given OQ is equal to 15. Let the height of the tower PQ is equal to H. Let O be the observing point. Given OQ is equal to 15 meters. That's all. And angle, this angle is given in the problem, 45 degrees. Angle QOP. See, this is given 15. This is given 45. That is, we are taking it as H. We have to find it. From the adjacent figure. Problem deals with which sides? What is the name of the side for this angle? What is the name of the side? Opposite side. This is called opposite side. This is called adjacent side. Opposite side, adjacent side. Opposite side, adjacent side. So the ratio is tan. See here, don't write. Tan theta is equal to opposite by adjacent. This is the formula. What is theta? 45. What is the opposite side? H. What is the adjacent side? 15. See, read the question once. There is a tower. Where is the tower? This is a tower. Foot of the tower, top of the tower. From the foot of the tower, at 15 meters distance, we are standing. We are standing here. So by using that instrument, we observe the top of the tower with angle 45 degrees. So this O is the observing point. PQ is the tower. Let its height be H. We have to find H. O is the observer. Q is the foot of the tower. P is the top of the tower. This angle QOP is 45 degrees. Now I am using tan because these two sides, this is not, no need. This is not given and we are not asked also. The problem deals with this side and this side. What is the name of this side? Opposite side. It is opposite to angle. No, this is called opposite side. This is called adjacent side. So tan theta is opposite by adjacent. Theta is 45 is equal to, what is the opposite? H. What is the adjacent? 15. Tan 45 is 1. Tan 45 is 1. 15 into 1, 15. This is the height of the tower. So therefore, write down height of the tower. This is the procedure. Same model. All problems are same model. So tower or tree or building, mountain, anything will be drawn vertically only. We will stand at a particular distance. That distance will be given. Angle will be given. So we are asked to find the height of the tree or height of the tower, height of the pole, height of the mountain, height of the building, any object. What is the height? Same, tan only. H by 15 is equal to tan 45. Tan 45 value, see the tables. Tan 45 is 1. 15 into 1, 15. Height of the tower is equal to 15 meters. Right.